Hey there, so in this video we're just going to talk about blood gases real quick and some of their components before we get further into the different types of acidosis and alkalosis. So first off, what are blood gases for? Basically they tell us the acidosis versus alkalosis of a patient's blood. And in doing so we can get a little bit more insight into different levels of organ function. Um, Typically we can learn more about the lungs and the kidney function. And that will become more self-evident as we go through the different components. So first off, as far as the components of a blood gas, when you send this lab, you're going to get results, and it's going to have the following things listed. So the first thing is going to be the pH, so how acidotic versus alkalotic is the patient. You may remember this from chemistry, but so normal blood levels are going to be somewhere between 7.35 and 7.45. And obviously, as those numbers go down, that's going to be more acid. And as those numbers go up, that's going to be more alkalotic. The next thing is the PaO2, or the partial pressure of oxygen. And that's just a fancy way of saying how much pressure are the oxygen molecules exerting on the blood, basically. How much external pressure are those oxygen molecules exerting? And that is going to be normal anywhere from 80 to 100. And that basically indicates how much oxygen is carried in the blood. The PaCO2, very similar, is going to be the partial pressure of carbon dioxide. Again, tells you how much CO2 is being carried, and this normal is going to be 35 to 45. And so as this number goes up, you're going to become more acidotic. That's what we would call an inverse relationship. And this is one of the first ways, along with the PaO2, that you can really start to determine what does the lung function look like. So between these first three, it's really going to be how is the lung performing. Right, so how well can you oxygenate, how well can you ventilate, and what is the saturation? So that's the next thing here that we're going to talk about. What is the percentage of available hemoglobin that is saturated with oxygen? So that's what the SaO2 is. And then you would, if you were doing this actual equation, is the percentage of available hemoglobin. That's what the SaO2 actually refers to, and normal there is going to be anywhere from 94 to 100. May see some different numbers now after COVID, sometimes going down 90, 92, considered normal, but typically that was the thought process. And between those three numbers, you can really start to get a good idea of the lung status for your patient. How well are they oxygenating? How well are they ventilating? Are they holding on to CO2 and then becoming more acidotic? Are they hyperventilating and becoming alkalotic? Are they able to maintain their saturation with the amount of oxygenation that they're able to achieve? All these kind of things you can learn from the pH and the PaO2, PaCO2, and the saturation. The next thing that we're going to talk about is the HCO3, and that is the plasma bicarb level. And normal here is going to be 22 to 26 milliequivalents per liter. And that is going to basically determine status of metabolic alkalosis versus metabolic acidosis, typically depending on where that number goes. And lastly, a base excess or deficit, and you're going to see that also on your ABGs and important thing to know is when this number is high is when it's alkalotic. And it's acidotic if this number is low. And we can go more into depth about the base excess in a future video, but in this one we just want to kind of talk about what are all the components of a blood gas. And if there's any questions before we hop into more about acidosis and respiratory acidosis and metabolic acidosis and alkalosis and all that stuff, then feel free to just leave them as a comment and we'll be more than happy to get to them when we can. Have a good one. Bye.